For question number 5, it says write a recursive and explicit equation to represent the number of candy in the machine compared to the number of customers. Just so we don't have to flip back and forth, I created the table that we had in question number 2. So I have that right here. We talked about the number of customers. I just went to 4 this time, and the number of pieces of candy and how much that was. And we talked about back again in question 2 and some other questions that we have a common difference of -7. So we're going down by 7 each time. So in order to write our recursive formula, I'm going to go straight to that function notation this time. We can go ahead and take P of C, and that's going to be equal to that previous term, so P of C minus 1. So remember, this is the current, this represents the previous term, and what we're doing each time is we're subtracting 7, so we'd say minus 7. And then we do have to list that first term, so we also have to write down that P of 0 is equal to 2700. Then we'll get to our explicit formula. So in our explicit formula, like we've been doing in some of our other tasks in our practice, is we've been writing out our table just to show how many times we're subtracting or adding, whatever that common difference is. So this time, if we take a look, this would be 2700. We're not subtracting 7 at all, so the number of -7s here would be 0. Then we would take our 2700 and subtract 7. That would give us 1 minus 7. Then we'd take 2700, we would subtract 7 and subtract 7 again, giving us 2 -7s. And so if we just compare real quick these few that we've looked at, the number of 7s matches exactly with the number of customers. And that's the idea that we need in order to write that explicit formula. So our explicit formula, we'll start with our P of C. And that's going to equal whatever we started with, which is at 2700. And this time we're subtracting 7, so minus 7. And we're subtracting that 7, the same number as our customers, which is C. So there we go. We have our recursive and our explicit formulas.